So this second video is the multiple choice where you are allowed to use the calculator. It's going to be much shorter than the other section because there's only like half that number of questions. This one doesn't even seem to need a calculator. You have a swimming pool. It's shaped like a decagon or something. It's filled with water. There's a pump that removes water from the pool until the pool's empty. So you have an empty pool. Then, when the pump is running, the rate at which the volume of water in the pool decreases is constant. So basically, the pool starts off with a lot of water, and eventually it has no water. But there's a lot of ways that you can get from full to empty, and that's what these graphs are showing. So it says the rate at which the volume decreases is constant. During the first 2 hours, the pump works slower than usual due to a broken piece. So what that means is that you see over here when the pump is, if the pump wasn't working at all, it would be flat like that. If the pump was like really working well, it would be steep like that. But the pump is the steepness is going to be less in the beginning than it is later. So that's why this is a candidate. And this is also a candidate because you say first it's kind of emptying slowly. But let's see what actually ends up happening. So, because they give more information. Then the pump stops working. That's why you've got this flat spot, but that's in actually all of them. So that's the broken piece is replaced. The pump works at its usual rate until the pool is completely emptied. The entire process takes 6 hours. So it's kind of funny, this question. Which of the following could depict the situation? What's confusing about this one, it doesn't need a calculator at all, but I feel like it's not this one because the pump was working fast, stopped, pump working fast. It could be this one, pump is slow, stopped, pump is working fast. It's not this one because here the pump is working fast, stopped, pump is still working fast. But my issue is with B and D because but it's only the first 2 hours. So that's why it's B. So 2 hours is where it stops. Whereas D, it runs for 4 hours, then stops, and then pumps really fast. So it is B and not D. No calculator needed. No idea why calculator was even part of that. In a certain simulation, the population of a bacteria colony can be modeled using a geometric series, where the first day is 1. So on day 1, we don't know, but 2, 3, day 4, it was 4,000. And day 5, 6, 7, 8 was 49,000. And their question is, what was it on day 6? Okay, well, it's definitely not D. It's bigger than 4,000, but it's less than 49,000. So if it's a geometric sequence, you multiply 4,000 by something, and we don't know what, but by something, and it gets to the 5th term, and multiply that by the same something, and then multiply that by the same something. So it becomes 4,000, 4,000x, 4,000x squared, and then to get to day 8, it's 4,000x cubed. So we want to know what 4,000x squared is, but we don't know x. But that's where the 49,000 comes in handy, because you can solve the equation 4,000 x cubed equals 49,000. Divide both sides by 4,000, and you're going to take the cube root of 49 over 4. Now this is where we can use the calculator. So this is when we use a calculator, and when you pop it into the calculator, you find that x is approximately 2.3 which is probably good enough for this multiple choice question, because now they want to know what happened on day 6. So you just take 4,000 and multiply it by this number squared. Now I kept that number into my calculator, so I just say squared and then times 4,000, and I get 21256. Which is not, let's see, 5, 6, 7, 8, x squared, x cubed. Oh, so I made a slight mistake. This should be x to the 4th power. That should be to the 4th power. This should be the 4th root. It will not be 2.3 anymore. To do the 4th root on the calculator, I'll do 49 over 4 in parentheses, and I'll raise it to the 1/4 power. There's also a 4th root or xth root thing. So it's actually 1.87. And 4,000 times that square is 14,000. Makes me feel like this one could have been done with no calculator. Let's see. Such a nice number. It's times 3.5. I don't know. Well, that's the answer, though. And sorry for the snafu on that one. Here, the rate of people entering a subway car is modeled by this function. So you put t in, anything from 0 to 20, and it tells you the rate or how many people are coming in the car into the subway. People per hour. T is measured in hours. Based on the model, at what value of t does the rate of people entering the subway car change from increasing to decreasing? So what they're getting at is that if you graph this thing, maybe it looks something like that. They're basically asking what's the vertex of this sort of parabola-looking thing, but it's cubic, so it goes increasing to decreasing. So we have to pop this into a calculator, because the only other method involves like techniques from calculus, finding the turning point of a cubic. Now, when I popped this equation into the calculator and made the top number, the y max, around 20, the thing looks something like this. So they were asking, what is the x-coordinate for that? So I think on the AP test, they even let you use Desmos, I think. But on the TA calculator, you do second trace, which is calc. You go to maximum. It wants to know, like, can you pick a point a little bit to the left of that high point and then a little bit to the right? And then it says guess. And when I did on my calculator, I got a number, looks like about 8.6. Hold on a second. Actually, my vision wasn't that good. It ended up being 5.505. So I had to change my window to get a Y max of 20. But that's what ended up happening. So they were basically asking in this question, where is the turning point of this cubic function? Here's a table. Function values 1, 2, 3, 4, 5, 30, 50, 83, 139, 231. And they want to know about a semi-log plot. A semi-log plot is where you can see on here, 1, 10, 100, they kind of smush the numbers together in such a way where if something was going to be exponential, they smush it so that it turns into a straight line. So in this question, maybe they wanted you to just verify first. If you do 50 divided by 30, you get about 1.6. And if you do 83 divided by 50, you also get around 1.6. So this thing is exponential. Now, 30, 50, I wonder, I'm just looking at this. So notice here, 0, 50, 100, that's not semilog. Semilog, this distance is, they sort of compress it down for this one so that it's not always 10 times as much, but it's some factor. So this is our best chance. Actually, you can see this is 30 and 50. At least they're both less than 100, and then 83. Yeah, this is the answer. Basically, an exponential curve looks like a line when you change the graph paper, so it's semilog. And that's why the answer to this one is choice C. See, this one here's not right. First of all, this thing's all linear, equal spacing for equal things. This one, 1 to 10, this could be logarithmic, the way that the things shrink. But the problem is this is, we want to get 30 as the first point. So 30 would be way, if this is 10, 30, where does 30 go? 30 is between 10 and 100. So here is the height of the tide, and it's modeled by a cosine curve. Something like that. So if you were to graph this thing, the 7.5 would be the middle line. The 6.3 would be that the high is 6.3 above 7.5, which is 13.8. And the low is the amplitude. The low would be 7.5 minus 6.3, which is 1.2. So this thing would look like that. So the maximum height is 13.8. That's true, and this question's done. But let's check the other choices. The maximum height the maximum height doesn't occur at 6. This is 6. It happens at 0 and 12. The way cosine curve starts at its high point. The minimum point is not actually 1, but it's 1.2. It's close to 1. The minimum height of the tide occurs at t equals 12. No, the minimum is at 6. So this one's A. Okay, here's another trig function. A sine B parentheses x plus C plus D. If the points, so they're telling us that 2, 2 is a minimum value, and 4, 4 is a maximum value. Interesting. What's the values of A and D? So basically, this is a funny question because a sine curve, here's like the minimum turns into the maximum, and eventually, if from 2 to 4 is from min to max, then from 4 to 6 is going to be back, and then from 6 to 8 is going to be the maximum again. So here's our sine curve. Maybe it like starts from here, but none of that actually matters because the A and D value, the D is the middle line. So if 4 is the max and 2 is the min, then D is 3. And the A value is the amplitude. So 3 plus 1 is 4, 3 minus 1 is 2, so A is 1. So all this is kind of confusing with all these numbers, but all that really mattered was that the low point was at 2 and the high point was at 4. Nothing else mattered for this question. I mean, they could figure out what C is. C is the shift, so C is negative 3. And B is actually kind of annoying. It's 2 pi over the period. The period is actually 4 because it's 2 units to get from the high to the low, which is sort of half of a curve. But that wasn't what was asked, so it was just A. Okay, so here's a function, and they want to figure out S of 12. But you can't put 12 in just yet, because as you can see in this equation, 12 would go in for T, but we don't know what K is. So this is actually two questions in one. First, we have to find K. First, we have to find K by solving the equation 300,000 is equal to 500,000 over 1 plus 0.4 e to the k, e to the 12k. No, e to the 4k. K times t is 4, because we're plugging 4 in to get 300,000. Now, solving this, it's a little annoying. I'm going to cross multiply and get 300,000 plus, now 0.4 times 300,000 is probably 120,000. It is 120,000 e to the 4k equals 500,000. Now you subtract 300,000 from both sides, and you get 120,000 e to the, no, it is 4k. E to the 4k is equal to 200,000. Divide both sides by 120,000. I like to get rid of all these zeros. So 20 over 12, calculator time. And you get 1 2/3. 1.66667. It's a multiple choice question, so you could write 1.67, probably be good enough. Now we have to solve for k. And for that, we use the fact that ln, e to the something, if you ever have an expression like e to the a equals b, it's also true that ln of b equals a. So when I see this, I could say ln of 1.67 equals 4k, and then k is ln of 1.67 divided by 4. That you need the calculator for. ln of 1.67 divided by 4. And k is about 0.1282. Now that we know what k is, we can go back and plug it in to the original equation. And we could plug 12 in also. So S of 12, 500,000 over 1 plus 0.4 times e to the k, which again was 0.1282, times t, which is 12. So that will be annoying, but on my calculator, 500,000 divided by parentheses 1 plus 0.4. Second ln gives me an e to the, I have the answer stored, so I'll go second answer times 12. I hope I did this right. I ended up with an answer of 174,642, which is close enough to choice A, and that's what I'm going with. Okay, just 5 more questions now. So you have 2 functions, K and M. They represent the sales of a product at a group of grocery stores. K of t and M of t are the sales of the product in thousands of units after t weeks. And this is very confusing. For t, so if K is 2 different things, are they're like competing to see which one's the model? They're constructed to represent the sales of a product at a group of grocery stores. Both represent the sales of the product. How can both? I guess they're, I don't know. They're different functions. Well, let's see what they want to know. Okay, so they're both supposed to predict sales. That's what's happening. What is the first time t that the sales predicted by the logarithmic model, that's k, will be 0.01 thousand units more than sales predicted by the linear model? So I think they're asking, when is 14 minus 2.885 ln(t), when is it equal? It's 0.1 thousand more, and this is thousands. So when is it equal to negative t plus 14.1? That's what I think this is asking. And the best way to do this one is by graphing the two functions and seeing where they intersect. But notice I had to put the 0.1 there, because it doesn't say when will the models have the same prediction. They want to know, when is the sales predicted by the logarithmic this much more than the other model. So I want to know, when does it equal with this extra 0.1 in there. So for this, I would plot both of these on a calculator, including this 0.1 here, and see where they intersect. So when I graph these, and I made the y max around 15, it ends up looking something like this. So they were asking, what's the x-coordinate of that point? For that, on the TI calculator, I go second calc intersects, which is number 5, first curve, second curve, and then it says guess. And when I did that, it looks like I get about, my eyes aren't so good, but it looks like about 1.807, which, as you can see, is not one of the 4 choices. So I'm going to have to revisit this for a second. Oh, I see. They don't want that answer because it's not bigger than 2. So they want this second answer. Let me see what that is. Hold on. Okay, so the second point ended up agreeing with it. So it's funny they didn't put that 1.8 as one of the answer choices. The tricky thing about this question, though, I think, is if you don't put the 0.1 there, or if you put a 0.1 here instead, you get one of the answer choices, probably one of the wrong answer choices. Okay, here's a function. Now that's not something that's real familiar. Separately, you might know what these look like, but together, that's pretty hard. That's not easy. So, cosine, when you add a sine and a cosine, you get a really weird, jagged-looking thing. Let me see what it looks like just in general. So I graphed it, and it was pretty crazy looking. It kind of had, starting from here, it kind of went under and over and under, and then it went up big, and then back down, and then it repeated. So each thing was like this weird, it was basically this like this letter M thing, and then another one. So what I think I would do is I would try to find the x-coordinate of 2 of these minimums, and that would tell me what the period was. So I'm going to zoom in on one of these and just kind of see what the x-coordinate is. So it ends up being about 1.23 and 4.37. In other words, each thing was about 3. I'm not sure what it exactly is. Maybe it's pi. Yeah, it's pi, after all. Maybe there's some way that we should have known that, but I didn't know that. So then they want to know how many complete cycles. How many complete cycles are there? So I would just do 1,000 divided by pi, which I assume is going to be about 318 based on those choices. Yeah, 318. Now, there might be some way of knowing what the period of this weird thing is, but that's not something that I know. So, because the period of cosine 2x is 2 pi over 2, which is pi. Maybe it's like the one that's got the bigger period. I just don't know. But I do know that 1,000 divided by pi is 318, which is the answer to that question. Okay, 3 more. Wow, this one's a little bit easier. So an inverse function is one where I'm going to make it red. So an inverse function, when you graph it, the x and y values change. So 0, 0 stays as 0, 0. 3, 3 stays as 3, 3. But here, 4, 5 turns into 5, 4. I don't like that these squares are not perfect squares because it distorts it a bit. And 5, 7 becomes 7, 5. So this red thing is the inverse. And they want to know what's the maximum value of the inverse. Well, I guess it's 5. That's a weird question. Okay, here the function, we have this sine function, and we have a second function. And they want to know, are they not? Oh, the g function is based on the f function. So weird. So basically they're just saying that g of x is sine of 2.25x plus 0.2, and then plus 0.05, kind of shifted upward. In my mind, I would just graph this. It's going to be it's going to be something like that. They just went from 0 to pi. I don't know. We're going to find out. Maybe there's just one. No, obviously there's more than one. Yeah, this is just a graphing question. So I would graph this function on the calculator, and I would find the x-intercepts. Let me try to do that. So when I graph this thing, it ended up looking like that. So there were only 2 x-intercepts. And for this, I think if I go to trace, I could just kind of move around and see about 1.53 and about 2.4, which is choice C. So this is a graphing question. I don't know. They threw the 0.5 in there. They made this more confusing than it needs to be, but that's what they did. And this is the last of the multiple choice questions. We have a wheel of radius 2. It's rotated at a constant rate. The figure provides a representation of the wheel, xy plane, direction of rotation, so it's going counterclockwise. At 0, it begins to rotate, and P is in the start position. At time 20, 120 rotations have been completed, and P is in the same position. Yeah, after any rotation, it's back in the same position. A sinusoidal function, which is the appropriate model. So after 20 minutes, 120 rotations have happened. So one rotation happened over 20 over 120, which is 1/6 of a minute. So I'm going to go like that. 1/6 of a minute is a single rotation where P starts off here, then it goes to its high point, and then back to its middle point, and then to its low point. Basically, this 20 minutes at 120 rotations is just a fancy way of saying one rotation takes 1/6 of a minute. So the equation of this thing, you can see that 2 is the high point and -2 is the low point. So it's 2 sine bracket t. We don't need anything here because the middle line is at 0. And we don't need anything here because it's not shifted, it's starting at 0. X equals 0 is the starting point. So the only thing that needs to go is here, and that's the b value. Well, the rule is that b is 2 pi over the period, and the period is 1/6. So 2 pi over 1/6 is 12 pi. And that is why the answer was choice D. So a little confusing about the 20 minutes and 120 rotations. They just wanted to make it annoying. That was their fancy way of saying that one rotation takes 1/6 of a minute. Okay, well, that's going to do it for this video. So this one's shorter than the other. Now we've gone through all the multiple choice of the sample test. And the next video, I'll do the 4, maybe not all 4, maybe 2 and 2, I don't know. But I'll do the part 2s in the next video or 2.